Hello students, this is the course instructor Jin Kook Lee, BIM and Design Media. Now we are on 09, ninth week. Wow, it's time flies, right? Actually, it's November, right? November. It's crazy fast time schedule. Probably you are in sort of hectic schedule because of the midterm exam and the formal part of the semester. Everyone always busy at the beginning of something, but we couldn't say it is beginning now because we are just remained rest of the half this semester. So winter is coming, Christmas is coming. So after changing the class title from digital design media to BIM and design media, now at least you all know how to use Revit, how to understand BIM, how to take advantages of BIM. And the two perspectives, they are Revit and Enscape. Then also we dealt with a lot of some geometric modelers. When you're freshman, AutoCAD, SketchUp, V-Ray, and so on. Now, at this semester, in this class, you have learned representative and very powerful, sort of typical 3D geometric modeler, 3D Max, using 3D Max, right? And some associated renderers, some real-time renderers, but representatively, Arnold CPU renderer you used on top of 3D Max. But now we have very powerful and kind of free student software, Revit, very good for modeling, especially building modeling, and really good and fast, as well as some fancy visualization renderer, Enscape, and some other GPU-based renderers. So anyway, why we are learning those things, BIM and design media? For better design. Okay, we approach to better design without any unnecessary technical problems. That is why we have learned BIM and design media, Photoshop, Illustrator, some 2D computer graphics, animation making, CPU renders, real-time renders, GPU renders, and some expensive computers equipped in our multimedia room at Samsung Hall. All these environments for your better design. Okay, but actually it is kind of narrow definition of this class. Why we learn this kind of technologies in narrow definition for making better design. But what is broader definition? What is broader meaning of learning those things, those headache technologies? It is for design computing. It's kind of broad definition, but in a nutshell, it's almost the same, I think. Design computing, almost the same approach, same term like BIM or CAD, even CAD, conventional CAD. But my point is, thanks to computing technologies, techniques, you can enhance your design, but sometimes we can find out some hidden meaning of design, or we can find out something new that couldn't be explored before that technologies. Think about nowadays generative AIs or something. It changes a lot. That is why we are calling it ground shaking technology or something. But anyway, in narrow definition, we are using those tools for design. So that is why this week title is here, BIM enabled design approach. Okay, it's not just using BIM. Okay, BIM enabled means thanks to BIM we can do something more than before. Okay, that's some different thing. Using BIM or BIM based means just using Revit. So far you are using Revit, you are adopting BIM based design approach. But my point here is, don't forget, BIM enabled design approach. Okay, so in the following section and following lab exercises and rest of things you're gonna do in the class, don't forget, we are doing now something beyond BIM-based design, but BIM-enabled design. Okay, I know it's not that easy to figure out at this moment, but think about the beginning of this semester. You don't know Revit, you don't know what is BIM, you don't care, and you don't much interested, but now you clearly make comparison between geometric modeling and information modeling, building information modeling. The abbreviation of building information modeling is BIM, right? So now you can theoretically understand BIM, and you can depict what is the future of BIM and so on, hopefully. So let's move on. Okay, BIM enabled design approach from this rest of half semester. Okay, and then also some final project announcement going to be released, and you can reuse your former studio work or current this semester's other classes studio work and so on. And then my point is, using BIM, try to find out something new, something beyond formal approaches. That is BIM enabled design approach. Okay. So this week's material, let's quickly review this predefined schedule. So far, we have walked through a lot of LEs, reading assignments, questions, mostly for learning new software such as 3D Max, Arnold renderer, CPU renderer, Revit, and GPU renderer Enscape. So from now, I hope learning tools and now using tools from now on. Okay, hopefully. I know you still need to learn, but as we modeled compact house, the same compact house you have learned last year for your SketchUp geometric modeling, you learned how Revit and BIM tool has some kind of efficiency and productivity compared to the former approaches. So from now, some kind of advanced things and new design approaches, as well as your ongoing or former projects, can be empowered by using Revit and BIM. Okay. Moreover, some 2D computer graphics, because all design should be represented in some kind of easy to read presentation material. So we need to prepare this one as well. So from this week, hopefully, as you get used to it, taking this lecture first, as always, and some additional review lecture, if there is, taking the review lecture video as well, and then move on to the lab exercises, reading assignments, questions, and so on. In a certain point, somewhere here, no more reading assignments and questions, but until then, don't forget, you have obligation to walk through all these given material. Okay, so now, so far we learned geometric modeling tool using 3D Max, Arnold, and some more. Some beginning with some 2D computer graphics. Mostly we learned Revit, BIM in theory and in practices, exercises. Now we're gonna learn something advanced in Revit plus 3D Max geometric modeling comparison, renderers, visualizations, some BIM enabled design approaches, and then interior architectural design representation and presentation using your project. Okay, then go to the final. Winter, Christmas is coming. Hopefully rest of the semester you can enjoy more. Okay, trust me, you can do that. Okay, let's move on. Let's take a look at this timeline again. I told you before, at the beginning of this method, this class, I simply told you that our history, I mean digital design technologies history, it's not that old, okay? Around the 60s, 1970s, that's kind of our most ancestors period, right? So around 50, 60 years compared to the history of architecture or compared to history of human being, this is really tiny kind of dust weight portion in the perspective of history. Anyway, take a look. The first CAD system, Sketchpad, first architectural CAD system, very well-known AutoCAD system in 1990s, and the Revit in 2000 to 2010. It's commonly popular in architectural firm or some industry. And next phase, okay? We are in here, 2020. Before and after 2020, you know that some artificial intelligence, specifically deep learning, machine learning, since AlphaGo hit our society several years ago. You remember that, right? Anyway, since then, we got a kind of sudden change thanks to this kind of new technologies. Anyway, this is a brief history of design technologies, and on the y-axis shows you some amount of information, its quality and quantity. Take a look what this graph means. How many data, how quantifying or qualified data amounts are raised up in this phase. At first, this is so-called, simply say, SketchUp, AutoCAD, Rhino, Max, 3D Max, and so on. That is why we had our focus always was on elevation section floor plans, so-called triple set of industry standardized drawings in our domain, architecture, interior design, whatever, okay? But we are handling BIM in this class, so a lot of things we can do. Simply imagine where you are now. Where are you? I think before this class, you are somewhere here. I know probably some of you can be stuck in this early phase of CAD, or someone's here, but that's totally fine, okay? Anyway, I assume that most of you students are in this phase, okay? In this phase. But in this class, since a couple of weeks ago, 3 weeks ago, you have installed Revit and you learned how to model your objects using architectural libraries. Now you know how to download library, how to embed that downloaded object to your model, your small building test model, or you can simply import just mere geometry from 3D warehouse, or your teammate, or your last semester's design studio work, just DWG file, SketchUp file, can be directly imported into your BIM model. And now you know at least how to render it, how to visualize that model. I know that. That's really useful for design. So now your data, your amount of data, your quality of data, now going up and up week by week, I believe. And that's true. So I think today you are somewhere here, right? I hope so. Anyway, but the problem is if you know very well about using Revit, now you are expert. Simply imagine that you are an expert in using Revit. Somewhere here. Does it mean that you are an enabled man in Revit? Now you are a sort of super girl in using Revit or using BIM? No, because take a look this one. Some more aspects of things, for example, extracting your floor plans, extracting very professional industry standard drawings, these ones, they used to be the subject for drawing. At that time, your goal was exactly on those drawings. But now your subject, now your goal is not this one. Now your goal is BIM enabled design. In other words, I can tell you that is BIM application. Okay, sorry, it's not a strike. Anyway, BIM applications include a lot of applications enabled by using BIM. For example, solar study, energy analysis, architectural program review, area calculation or something, circulation checking, code checking, code compliance checking, and so on. Even in the perspective, even in the scope of design, there are a lot many more things enabled by BIM, enabled by Revit. Okay, so even if you are going to be an expert in Revit, that's going to be your starting point of BIM applications. Lots of things here. Actually, the next topic, next issue mentioned in your flip learning video. At that slide, simply say that can be defined something like this: artificial intelligence and BIM, artificial intelligence with BIM, or BIM or AI enabled BIM or something. I'm not sure what it is, but one thing sure that I can tell you now is it's even more really super advanced technologies in BIM domain, thanks to even more cutting-edge technologies. So don't forget, you are a couple of weeks ago you were here, and now you are here, you are climbing, and next week and after next week you are going to be an expert in Revit, I believe, and you should prove it. Okay, anyway, by using our series of projects, you are kind of enabled, you are able to perform more BIM applications. This doesn't mean that you can skip some aesthetic aspects of design, or some design visualization or design representation is not that critical. I don't mean that, okay? My point is, you mostly focused on design visualization. Okay, but I know this is important as well. Of course, this is very critical. I know that, but there are something more, a lot more actually, a lot more. So we are take a look at a little bit more focus on these alpha things, these more things. They are BIM application. Okay, let me, okay, here AI add some advanced things. let me clean up and let me show you this one again. So next thing here, some human behavior data, smart city data, spatial data, and so-called big data, AI enabled something, blah blah. Actually, these are out of scope. This is not your next phase, okay? Your next phase things are here, okay? These are even next things. Actually, they are sort of graduation students level or graduation. I mean the first year students or some graduate school, okay? Graduate school class topic or some research topics. Very ongoing things. And take a look this part. Geometric modeling, drawing oriented design, something else. They are so-called very mature, how can I say, mature technologies. In other words, conventional. And this part, this is so-called a little bit premature or mature, we can say mature techs, and current technologies, okay? Now we are here. Again, you used to be here at the beginning of the semester. Now you are climbing this mountain. And in a couple of weeks, hopefully, you are here, okay? Probably here, okay? And next thing, this part, issues, I told you in the previous slide, BIM applications, okay? In other words, take a look this term, BIM for X, or we can say this one, design for X. Actually, X can be anything. This X can be replaced with anything. For example, visualization. Think about that. You are working with SketchUp, AutoCAD. For what? For the final presentation or some progress presentation to your design studio instructor. So your main purpose used to be mostly visualization, representation. Fundamental X could be visualization, and even in this semester for the final project, anyway, at the end, visualization matters, very important. So I told you, I don't mean that visualization is not important. This is still very important. But my point today here actually is bringing more attention to some other axes. For example, design for solar study. When you need to some sustainable design or energy saving design or some green design, whatever, this thing is very important. Or if you have some troublesome with surrounding buildings or some community issues, for example, your site's very low-rise building community, but you want to build some high-rise, mid-rise buildings. How to alleviate some complaints from your community? You need to show them on evidence that your building is not that critical based upon your solar study or something, okay? And how about code checking? the term code here means legislation. I mean some binding force law, okay? Your building supposed to be under the control of governors law, okay? Local law or federal law, whatever. Anyway, you have code, fire code, building code, some safety code, disabled act related code, and so on. So code checking can be done. And area calculation. In other words, architectural program review. Sometimes your area calculation very critical when if you are designing some commercial building, some spaces are big, some spaces are small, you need to exactly compute area numbers in order to make the maximum benefit, because area equivalent to your rent money, monthly payment. Okay, small area, small money, bigger space, bigger money, of course. So sometimes area calculation very critical. How about circulation? Circulation is very critical in architectural planning and spatial layouting. Okay, you know that spatial allocation matters because convenient access or very inconvenient and very efficient or some troubled, some badly designed spatial allocation lead to some bad circulation and some satisfaction quality going to be getting very low, right? The community and some tenants satisfaction and so on. The users satisfaction in building performance includes a lot. Circulation is that one part. Okay, how about energy calculation? This is also very important when you are concerning some energy bills. This is also very important as well. How about the actually a lot more things. I can show you an example, but in Revit fundamental interface there are some more. For example, solar study, code checking, area calculation, circulation checking. Just a second. Okay, another thing, someone's interrupting me. Okay, anyway, how about cost estimation? Money matters as always, so this kind of thing also very important. How about this one? Construction planning. Construction related things, something after design. How about considering manufacturing? Actually, your reference, this week's reading assignment will show you DFMA, manufacturing assembly something. That means design for manufacture, assembly, construction. So BIM 4X, similarly, design 4X, this is actually the main subject, okay, main topic today, okay. There are a bunch of more applications and they are now sort of ongoing development. Thanks to this kind of variety of applications, we got a lot of some job opportunities, some research subjects and targets. We have a lot to work with. I'm the man who's working in this area as well, so actually, anyway, the last thing, even if we are working for this part, amount of BIM 4X, design 4X in this domain, there are some visible next phase things AI BIM I mentioned before. So all these are something programmed, something certainty-based things, so-called restricted data-based, but this one, huge size of data, so-called big data, can be collected from the existing buildings and some research results and so on. So how to use them in actual design, in actual projects. I'm very curious the result. And in my lab with my graduate students, researchers, recently my focus mostly on this part. Okay, hopefully you can move on this part after being an expert in Revit and BIM. Okay, quickly review and let me prove this one. How many applications are there? I showed you in flip learning video. This is actual projects have done in Yonsei. So if you stop by Yonsei actual site, you can see this project. Few years ago, we got this blueprints. I took this one using my iPhone and simply moved to Revit in 2 hours. Just 2 hours. Convert this analog blueprints, 30, 40-year-old blueprints into this BIM model. Why? We need to extend in horizontally and vertically, several directions. And we need to use BIM for structural analysis, design quality quantification and checking, and a lot of design alternatives applied to this new design, new remodel design and so on. Lots of things we have to simulate. Okay, as you see here, amount of site alternatives, design alternatives, a lot of units, many units, and existing plans. So those two things are actually not the conflict. They should be combined. Okay, they should be combined. So we build this one quickly and easily, very efficiently, okay, very productively, and then we made this output in very efficient way with amount of BIM applications. So design alternatives, and take a look. Unit A, Unit B, Unit C. So how many units, Unit A's, how many Unit B's, how many Unit C's in same building? Actually not even same. 3 different alternatives we have developed. That is why we can simply harmonize them so that we can make design, many variety of design alternatives in this way. So you saw that, right? Many design alternatives, as you see here. Unit A, Unit B, Unit C, and so on. Take a look. What if I use SketchUp, Max, Rhino, or AutoCAD for generating this one? I had to design again and again and again and again all the night for these several design alternatives. But thanks to Revit, this is Revit model, and auto extraction of plans. So this can be exported in DWG format. So you know that DWG format usually originally made by AutoCAD tool, but in this process no need of AutoCAD. But we can get DWZ. From AutoCAD? No, from Revit. Okay, so now the drawings are subject to be exported, not subject to be drawn or made by you. Because BIM, Revit supports this kind of auto generation, auto extraction of your DWG plans, elevation, section as well, without any additional efforts. But take a look this drawing, very looking professional, very industry standard things. That's my point. Okay, this is one of the BIM application we can say. As you see, based upon this time frame, we had first design number 1, number 2, 3, 4, 5, 6, 7, and other place 1, 2, 3. So how many design alternatives? Whenever we got new design, we implemented this design project using BIM, specifically using Revit. In single this model, we generate amount of BIM applications again and again with not that much unnecessary time or unnecessary efforts. Reasonable efforts and reasonable time spent, we generate this kind of very nice reports, reviewing results, BIM applications. For example, daylight analysis. This is so-called solar study. Take a look. This is the band of solar location, sun location. This is sun, okay? This is so-called sun study or solar study. Sun cannot be placed here or here, only inside of this band, okay? Because this one allocated the geospatial information correctly, and then we can do this. How about this one? Area calculation. Area calculation can be done using this space program related things. Take a look. This is Revit's room schedule. One of the subject for today's lab exercise. Okay, room schedule. For spatial program review. The term program here means not computer program. This is spatial program, okay, or architectural program. Architectural program review using this quantity, okay. Take a look. Space name, its area. Space name, its area. You can easily extract this one in automation without any unnecessary efforts. Okay, that's the point. How about preliminary energy analysis? You can make this kind of energy report by using Revit. Okay, this one shows you how much money you need to spend for energy bill annually based upon the standardized, international standardized energy calculation method. Okay, this kind of visualization, very good, you know that. And spatial program review, as I mentioned before, spatial program review. Take a look. If you have very complicated space allocation and their combinations, take a look. Very complicated combination. A unit for 8, unit for 6, unit for 2, unit for 3, unit for 1. This is so-called one room, okay? Office or one room, anyway. So how many households and how many people? So entire household, entire people, but this building can be simulated. And this kind of some graph chart-based visualization also available. Okay. Next one is circulation, building circulation. Take a look. This is circulation path graph. These can be generated nowadays even on top of Revit. So we're going to review that as well. By using Revit, you can generate this kind of circulation path graphs. And this path graph returns this kind of very, very precisely calculated distance. And this one can simply extract total working distance of this building is going to be 18 kilometers. Wow. How 18 kilometers can be derived from this building? Because this is total sum of these edges lengths. How about average distance, minimum distance from the gate, from the main gate, from the first floor main entrance? Minimum 12 meters, average 45, maximum 82, which means the closest unit from main entrance has 12 meters, very short. The most far from this main entrance, I don't know, somewhere here, this unit has total 82 meters walking distance from main gate. How to compute these numbers? Thanks to BIM, this was enabled. Okay. So now I'm 100% sure that now you fully understand why I mentioned BIM enabled design. This is so-called BIM enabled design. How to calculate this kind of numbers in automation? That's the point. Okay. Some more cases, more examples.